Let's have a look at question 21 and 22. Not very nice questions here, really. 21, which of the following changes, so increase in pressure adding the catalyst, increase in temperature and removing the carbon dioxide, does it affect the equilibrium yield of hydrogen? What the equilibrium yield of hydrogen means shift the position of equilibrium to the right to make more hydrogen. So effect on equilibrium of hydrogen, increase in the equilibrium yield of hydrogen would mean shifting it to the right to make more. Decrease in the equilibrium yield of hydrogen would mean shifting it to the left to make more. Effective value on equilibrium constant. Now that's interesting because the only thing that affects the value of the equilibrium constant is temperature. So increased temperature would increase the effect, would increase Kc, but decreasing Kc, the only way that we're going to affect Kc, either to decrease it or increase it, is to change temperature. That's the only thing that affects Kc. So Kc can't be decreased, changed by increasing pressure. A is definitely wrong. And also removing CO formed increase in Kc, no, that can't be right as well. So A and D are definitely wrong, because if we're going to change Kc, decrease it or increase it, as is the case in AC, we'd have to change the temperature, and it doesn't mention changing the temperature. So either B or C are correct. Increasing the temperature, increase on Kc, very possibly increasing the temperature could increase the Kc. This one, no effect on Kc, so maybe the catalyst could do that, have no effect on the Kc. There's only temperature that would change Kc, so no effect is plausible. So it's either B or C. Let's have a look. Adding the catalyst increases the yield of H2. Now, adding the catalyst doesn't shift the position of equilibrium to the right or the left. Adding the catalyst just speeds up the forward and backward reaction, so the equilibrium is achieved more quickly. So that's clearly wrong as well. It's not going to affect the position of equilibrium. So the answer is most definitely C. Let's just check out then. Increase in temperature changes, increase the value of Kc, very possibly. Increase in the temperature increases the effect, increases the yield of H2, in other words, makes more H2, shifts the equilibrium to the right. Let's check that. Increase in temperature, by Le Chatelier's principle, that it would try and lower the temperature of the system, of the surroundings. So would it shift to the right? Increase in temperature, Le Chatelier's principle say it will try and lower the temperature to oppose that change, and going to the right is endothermic, does take in heat. Yes, so more H2 would be produced. So taking in heat to lower the increased temperature and to oppose the change. C is the correct answer. Enthalpy value given in table 3. So this refers back to this reaction again. So the enthalpy change, let me just do spoilers, enthalpy change, bond enthalpy equals, or enthalpy change 206 equals bond enthalpy of the reactants take away bond enthalpy of the products. That's what BERP stands for. Bond enthalpy of the reactants take away bond enthalpy of the products. So 206, which is my enthalpy change, equals the bond enthalpy of the reactants. Now what's in the reactants? CH4. So what's the bond enthalpy of those CH4? 4 carbon to hydrogen bonds. Well, a carbon to hydrogen bonds is 413, and there's 4 of them, so 4 times 413 to represent those 4 bonds in CH4. An OH bond is a 463. In H2O there's an O to an H and no to H, so there's 2 OH bonds, so that's where I've got 2 times 463 for this enthalpy change. Now the products, take away the bond enthalpy of the products, so I've got to take away carbon monoxide, a carbon to oxygen double bond. It doesn't tell me that, so I'll just have to leave that as minus the carbon monoxide bond here. Is that what it wants me to find out? It does. It wants me to find this value out. Take away 3 lots of H2. So a H to H, a H2 is a 436. So I'm taking away 3 lots of 436. Take away 436. If I rearrange that equation, I'll end up with 206 equals 1652. That's this, the product of these here, plus 926, which is this one, minus the bond enthalpy change of bond enthalpy of carbon monoxide, which I don't know, minus 3 times 436 is minus 1308. I'll take these 206, actually I'll take the minus carbon monoxide to this side, so it ends up as a plus. So the minus CO bond enthalpy will come over here and end up as a plus. 1652 plus 926 minus 308, and my 206 comes over this side and ends up as a minus, so it's 1064. So your answer is B.